Okay, let's rock and roll, people. Let's rock and roll. Okay, so if we talk about what the focus for today is, in the last lesson, we learned how to find unknown sides and unknown angles in triangles. And one of the things we learned about would be something like, how do we find that blue dot? Now, who would like to tell me what that angle is, where the blue dot is, using what you learned in the last lesson? And you can put your hand up to let me know audibly, or you can put it in the chat. I'd love to see what you remember if you wanted to find that unknown angle over there. What would you use? What knowledge, what facts would you use? So pop your hand up if you want to pop an audio answer, or put it in the chat. What would that angle be that I've just highlighted? Who feels like they know? We know that angle's 48, that's 37. Let's go to Annie. It is so good to hear from you, Annie. Annie, can you hear me?
Hello, sir. Hello, sir.
Hey. How would you find this angle?
I think that you have to use sum of angles of a triangle. So it's 180 minus 48 minus 37.
Perfect. And what do we get? Have you managed to do that calculation yet?
No, let me take out the calculator.
Okay. The other thing while Annie's doing that is we normally have to give a reason sum of angles in a triangle.
It's 95, sir.
Okay, 95. Fantastic. Thank you, Annie, so much for your help there. So we could figure out what that angle is, no problem. And this is called solving a triangle. And so, you know, that was some of the ideas that we did in the last lesson, was using things like Pythagoras and using grade 10 trigonometry. But there's a problem with trying to find what this length x is over here. And in order to solve for this, we can't use grade 10 trigonometry. Why can't we use grade 10 trigonometry in this particular triangle? Okay, let's go to Masejo. So Masejo, why do you think grade 10 trigonometry will not cut the mustard in this one?
It is usually because this triangle is not right angled. So yeah, that's the reason.
Perfect. Couldn't have said it better myself. So the problem is that grade 10 trigonometry assumes all triangles in the world are right angled triangles if we're going to apply trig. And so this one isn't a right angled triangle. And so we need a new tool in our toolkit. And this tool that I'm going to show you today is called the sine rule, and it applies to all triangles. And so it's a very useful tool to have in your toolkit because you can solve for, it works for all triangles, including right angled triangles. And the way it works, I'm not going to do the proof today, I'm just going to show you, is you start by writing down what you want to figure out, which is the x. And you divide it by the sine of the angle opposite the x. So what's opposite the x? The angle is 48. And then we write, we need another matching pair. So what pair? I think I can see a 37 and I can see a 23. So I'm going to put the side on top, and on the bottom, I'm going to put the sine of 37. And this is what the sine rule says. It says, if you've got a pair of angles and sides, you can, the side divided by the side of the angle is equal to the other side divided by the side of the angle. And so I just want to show you how we would figure out what x is. In fact, maybe I should ask you the question. I want to get x by itself, and the sine of 48 is sitting at the bottom. How am I going to get the x by itself? Who would like to suggest a method for getting that to the other side? So Naomi has said, multiply both sides by sine 48, in which case you would get, basically you would get whatever you had here, and you could say times by sine 48 over 1. Or essentially what you're doing is you're saying, I'm going to times this side by sine 48, and I'm going to times this side by sine 48. Oh, excuse me. And then these will cancel. Okay, now I want you to put that into your calculator for me. And again, for now, I'm just showing this to you. You're not expected to do it. You're going to learn how to do this. What do you get if you go 23 divided by sine 37 and then equals times sine 48? Or I suppose you could write it like this in your calculator. Because that means the same thing. Because when you deal with fractions, you multiply along the top. So I want everyone to put this in their calculators and see what we get for the value of x. And I want to see a couple of different students. So to make sure that so I'm guessing that it has to be bigger than 23 because the angle 48 is bigger than 37. Maybe I should even bring up my calculator and show you how I would do it and use some magic here. Okay, if you could just tell me, can you see a calculator on the screen now? Is that showing nice and clearly? Here, can you see a calculator on the screen? So
the lesson itself is not show. Oh yeah, there I can see it. It's on now.
Okay, perfect. Okay, so I'm just going to type in here 23 times the sine of 48, and I'll put that over the sine of 37. And what do I get? Let's have a look. I get, and I hope the calculator was helpful to you, I get x is equal to 28.40. And so I've now found the unknown side. And let me look at the chat and see if it's looking good. It's looking good to me, 28.40. Okay. Now, you're not expected to know this perfectly, but give me a thumbs up if you just followed the basic rule. And give me a thumbs down if you're like, whoa, that was way too fast. I just want a quick little, because I just showed you an example now. You haven't done it by yourself yet. Okay. For those who are feeling unsure, let me show you what the law of sines looks like in terms of the theory statement. Okay, so say you have there's two ways of writing the sine rule. The one way of writing it is to write it with the sides on top. A, B, and C, little a, B, and C are the sides, and the sides are on top. The other way of writing it is with the sine of an angle on top and the sides at the bottom. So there's two different ways of writing this. But I want you to notice what happens. I write this side divided by the sine of that angle. And then I can say this side B divided by the sine of that angle there. So the sine rule is basically choose a side divided by the sine of the angle opposite, and that's equal to another side divided by the sine of the angle opposite. And if I could even do this, I could say C divided by the sine of C would also be equal. So I'm going to show you this again because I think we need to do quite a few of these. So let's try and talk about this one over here. I want you to think about, what do you think, first of all, if I look at solving this triangle, the unknown side is this x over here. I can't use normal SOHCAHTOA trigonometry because I don't have a 90-degree angle. So I have to use this new sine rule. So what I'm going to say to you is, can you write down, I'm going to suggest that your working out should look something like this. I want you to fill in the spaces here, 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 and here. I'm going to give you 30 seconds or so to write it down, and then I'm going to try from there. That's awesome to hear, Naomi. I love it when we line up with what's in class because it reinforces everything you're doing. And we are trying very hard to follow the caps, so we line up with schools this term as much as possible. Okay, I'll give you a hint. We want to know what x is. So I'm going to write x first. What do you think is going to go below x? I think, what's opposite x? Yep, 115 is opposite. So that's the one side. Now, what is going to be on the other side? We need another matching pair. And remember, it's the sine of 115, not just... so what other sides do we have? Feel like this 11, and remember, we're writing it with the sides on top. So 11, and then over here will be the sine of 48. Now, we're not done yet. We still have to do some working out. And this is where Lesedi was asking you about the extra step. So Lesedi, I want you to listen carefully now and also ask me a question if I lose you. What makes life difficult is that the sine of 115, it would be so much better if it could be on the other side. But I can't just take it there automatically. I need to do a valid mathematical operation. And so what I'm going to do is I'm going to times both sides by sine 115, right? So if you imagine, it's actually over 1, but the 1 goes to the bottom. So if I do that, it cancels this out and I get the x all by itself. And then I'm left with 11. And you don't even have to write the times. You can just write sine 115. So let me just put a dot there. 11 times sine over sine of 48. And now what we need to do is try and put this in our calculator in a nice way. So I'm going to show you what I do. I hit the fraction button. I go 11 times the sine of 115, and then I move it down, and then I go sine 48, and I hit equals. And so according to this, I get 13, x should be equal to 13.42 centimeters. And that makes sense to me because that's bigger than the 11, and the biggest side will always be opposite the biggest angle. Now, again, we need to practice this more, but I just want to get a sense of thumbs up if it's seeming okay, thumbs down if I'm completely losing you still. Okay. So you know what I feel coming on? I feel a bit of a multiple choice question coming on. So let us do, you know much I like multiple choice questions, such a big fan. I want you to try and answer this question by choosing the correct option. And what you're trying to do is you're trying to find the length of this side over here, x. So I'm going to give you some time, and in the chat, you can put what you think is the correct combination. Quite a bit of visual clutter up there, so see what you can do. Keep those answers coming. Is there anything that matches that? Yeah, it looks to me like option C would be the correct response. Because and again, there might be other ones that, but you remember, you have to really take heed of these pairs. Like you have a side and it pairs off with the side of the angle opposite it. So you need to make sure you've got the pairs in the right place. Okay. Cool. I like what I'm seeing in the chat. Looks good to me. So again, I encourage you to ask a question if I'm losing you, but if I'm not, then I'm going to assume we're okay. And let's try another one like this. This is the next step in the process. So which of these options do you think is, you given this to start with? You're given that. Now you need to get the x by itself. What do you think of? So Ayanda's asked a good question. Will it always be the sine function? So when you're using the sine rule, yes, I under it will be the sine, but there is something called a cos rule and an area rule, and I'll talk about those in future lessons. But for now, we're just learning how to use this tool called the sine rule. Which of these four options do we think is correct? So I need to get that sine of 54 to the other side. I feel like this one is just made up. Like that can't be right. I feel like sine 54, I'm looking for a times sine 54. Oh, it's in front. Sine 54 times. So I was looking for it at the back, but it's in the front here. And so it feels to me like that's what I was looking for, or that. So either A and C, but that's the wrong way around. So the correct answer is C. Cool. Looking good, looking good. Let's do another one, like something like that. Which of the following statements fits this diagram? Naomi, it won't give the same answer because it was flipped around. So in that example, you started with something, and so yeah. Which one do we think matches for this one? We have to be careful here. So I'm going to pair them up so my brain doesn't get confused. I'm pretty sure that's the one. And then I should have 21 over. Is there anything like that? Yeah, okay. So these are actually getting quite predictable now. So the good news is applying the sine rule isn't so bad. So let's go. I think the multiple choice questions have helped us kind of get used to the framework of this. Let us go and find an actual question where we have to find, no, that's a bit, we have enough multiple choice for now. Oh no, I don't want to do that. Let me find, so do this one. We go and find one quickly. Sorry guys, let me just jump down to the bottom where I know I've got some spares lurking. So we want to find, no, I don't want to get that one. I don't want that one. I don't want that one. Where did my thing go? No. Okay, let's go back and do one of these and I'll come back after. Find the size of Y. Let's do this one. Sorry, everyone, for that jumping around. Can you, if you're given this, which of the four options will be correct here? Which of these four options do you? Okay, let's have a look. I want to get the sine of 64 to the other side, and it becomes a multiplication. I know I've got 11 over the sine of 104. And so both B and D are looking interesting to me, but I need to watch what is over here. And it looks to me like this is the same, whereas this is a bit different. it must be the same because I bring this to the other side and it becomes a multiplication. So for me, I think the option is D is the correct answer. Give me a thumbs up if that makes sense to you. I see there were a couple of B's, but I hopefully I've shown you why it can't be B. And then I'd love everybody to, in this case, I want you to figure out what the value of this X is. So what is the value of this X? I know you've chosen the correct option, but now I want to tell you to tell me how long is that unknown side? Who can tell me how long that unknown side is? You might need to use your calculator. So I'll do it a slightly different way this time, but sine of 64, close bracket, times 11 over sine of 104. Moving on, and what do we get? It seems like the distance we get here is 10,19, and that is centimeters. Okay, so in the first half of the lesson, all I showed you how to do is when you're given a triangle with some missing side, and you've got a matching pair of sides and angles, like the scenario, you can use the sine rule, and it's actually really not hard to find that unknown side using the sine rule. Now, what we're going to do after the break is instead of using the sine rule to find sides, we're going to use the sine rule to find angles. And what that's going to mean is in this first part of the lesson, we were using that representation of the sine rule. And the reason we wrote the sides on top is what we were trying to find. After the break, you're going to find that I write the sine of an angle on top because we're actually trying to find out what the unknown angle is in that scenario. Okay, and so when we come back after the break, that's where we're going. But for now, what I need to do is I need everyone's cameras on. I want to see as many faces as possible. And I want you to stand up with me, and we are going to do some unwinding because our brains need a chance to just, I call it save as. They need to click save as. And so I want to see pictures on screen, and I want to see you all standing with me, and we are going to have a bit of fun. Okay, so step one, we're just going to shake our arms around, shake them around, pretend you're like a piece of licorice, and you just bend like this, shake out your feet and your legs. So let's see if you can get your feet up. Oh, I might pull a hamstring, watch out. And then let's start with a tricep stretch because you've been leaning forward. And while you're stretching, I want you to look off into the distance so that your eyes get a break. So you're focusing somewhere far away, and then switch to the other arm, look off into the distance, give those eyes a break. Okay, then come down. We're just going to roll our shoulders back 5 times. 3, 4, 5. Roll your shoulders forward. 2, 3, 4, 5. Arm across to stretch out. And then switch to the other side. Okay, shake out the arms again. Shake out the legs. Let's just do, we're going to do this thing where we go, breathe in, breathe out. We're going to do 3 of those. Okay, hope you enjoyed those nice deep breaths. And then for the last thing for today, we're going to do some heart rate raising activities to get the blood and oxygen moving in our bodies. We're going to do air skipping, and we're going to do 15 of them. So 3, 2, 1, let's go. 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. And there we go. Cool. And then what we are going to do, how much time have we got? Are we doing okay? Let me go to the brain break. So here is today's brain break. Can you work out what a lemon plus a watermelon plus a peach is? And then I thought I saw a question there from remember that we're trying to figure out what this thing at the bottom is. This is our brain puzzle for today. Corey. I guess this must be a 1. Yep, Tegavatso, I agree, that must be a 1. And then what can we solve next? I guess that must be a 5. Yep. So this is a fancy simultaneous equation, basically, but it's just kind of fun with the fruitiness. I guess this means lemon must be 7. Not lemon, sorry, watermelon. Yep. So Vatso and iPhone agree, which means the orange must be 2. So let's put these values in. What's my final answer going to be? Yes, Mdudu, Tegavatso. I think Feliciwa. I agree with you. The answer is 14. And Rai agrees. Tamelo, Elikle. Fantastic. Cool. All right. So I hope that your brain completely forgot about the sine rule for 3 or 4 minutes so that it can come back now and carry on learning. So let's look at a different variation of a sine rule question. So in this situation, you are asked to find the size of angle Y. And what are you given? You're given 2 sides. Now, again, if you went to your grade 10 toolkit, you would not be able to solve this thing because you can't use Pythagoras. There's no right angle. You can't use sum of angles in a triangle. You really don't have a tool except this new tool I've shown you today. So what are we going to do? Well, we'll start by writing the sine of the angle that I want to know. What do you think I'm going to write below that? So tell me in the chat, what do you think is going to go below that? So it's going to be the side that is opposite. So that's going to be 10. Now, what do you think is going to be written on the other side? That's what I want to know. Using the ideas of the sine rule that you've seen so far, the only other matching pair that I can see, it looks to me like 64 and 15 are involved. I must make sure I write down the right. So sine 64 over 15. Okay, now we're on the right track, but there's a problem. The problem is this 10 over here. I want to get the thing with the variable by itself. And so I want to ask, how do I get rid of this 10, or how do I make it less of a nuisance? if somebody wants to put their hand up, or if somebody wants to put in the chat, how do I deal with the 10? Multiply. Perfect. So we would get the sine of y is equal to 10 times the sine of 64 over 15. Now, we are not there yet, but we are getting warm. Remember, the goal was to find the value of y. We have an equation, but what happens when we want to get rid of sine? We can't just multiply both sides by sine. We have to use what's called the inverse sine function. Yes, Naomi, you are right. So what does that look like? The inverse sine function just applies the sine of -1 to both sides. And I'll show you in a moment what this looks like. Sorry, I've kind of run out of space here, so it gets a bit clumsy. But this is going to cancel all that out, and we get y is equal to the sine of -1 of what we had above. I want you to put that in your calculator and see what you get. And we'll talk in a moment. Apologies for all the... So let me put this in my calculator. I go shift sine. So notice how I'm saying to the calculator, I want an angle. And then I've got a fraction. I've got 10 times the sine of 64 over 15. And then I want to close my brackets. What are we getting? What are you guys getting for your answer? So I'm going to hit equals, and I get for my answer, y is equal to 36.81. And what that means is that this angle over here is 36.81. And what's so wonderful about this tool is that once you found out what that angle is, if you wanted to, you could easily find out that angle too. Okay, and so that's what I call applying the sine rule to find unknown angles. Oh, you can't see the calculator. My apologies, guys and girls. I forgot I had to switch to the other screen. Let me see if I can do it now. So let me do that again. So what I said was I said shift sine, and then I used the fraction button, and then I said 10 times the sine of 64 over 15, close the brackets, equals, and then I get that. Okay, give me a thumbs up if you followed that. Give me a thumbs down if you're feeling in any way unsure about how to do that. Okay. Well, then let's go and do another multiple choice question. In this multiple choice question, you are trying to find the unknown angle y up here. And I want you to choose of the 4 options, which one would be the right way to write the sine rule. Take a moment to just consider your options. What would you start by writing? You'd start by writing the sine of y over 7. And what's going to be on the other side? Sine of y over 7 is going to be equal to the sine of 34. Now, what's opposite that? It's 8. Is there anything that looks like that? So it's, yeah, that to me would make the answer A. So whenever you use the sine rule, you always go, is it this angle on top, or is it the side on top? And whatever you start with, you keep it the same on the other side. If you're finding angles, you put the angles at the top. If you're finding sides, you put the sides at the top. Okay. Now, let's go through that one. Let's do this one. Which of the final steps, so which of the following is a correct final step before inputting it into the calculator? So you're given this thing to start with, that the sine of y equals this, and you need to choose the correct option from these four here. Which one do you think would be correct? What am I looking for? What's the key little idea that I'm looking for? So I'm looking for the inverse sine when I'm finding an angle. And so none of these can be correct. Only this one can be correct. I want you to tell me what is the value of y. So I want you to put that in your calculator and find me the size of angle y. What are we going to get? So what do we get? I get 29. We get 29.29 degrees. And that's what the y up there is going to be. Yes, Chuma, Milikaya, you agree. I agree with you. Okay, you're doing so well. I don't want to go too fast. So again, I'm watching the chat and Ms. Kia is also watching the chat, but it seems like you guys are smashing this. So why don't you find for me the size of angle ABC? Now, what does it mean, angle ABC? It means ABC. It means this one here. So find me all by yourself, find me the angle ABC. Over to you guys. What do we get for that? So remember the sine of B or the ABC, this goes with this, but what's going to be the matching pair that goes with? It feels like it should go with the sine of 60 over 18. Like these two are connected. But remember, even when we got to this stage, we still have to deal with the 20. And then we still have to somehow get to the B somehow. So I'm going to give you some more time. What do we think that B is going to be? And remember, what do we use normal sine or do we use inverse sine when we have to work this out? Don't forget to close the bracket. what do we get for our answer? So we seem to get 74.21. 74.21 degrees. And that again makes me happy because 20 is longer than 18, which means this angle has to be bigger than the 60 because it's a bigger side that's opposite it. Quick show of hands, thumbs up if you're following, thumbs down if you're feeling a bit confused and I need to just slow down a bit. And be honest. Remember, you're quite anonymous here, which is quite nice. It's like you can be brutally honest. Okay, now if I am losing you, I want to maybe ask a question so I can see where I can help. I'll go through the steps again. Step one was, what was the angle that I was trying to find? And I was trying to find this one up here. So this one up here, angle ABC. And so I wrote the sine of that angle to start with, and then what's opposite this angle? It's the 20. So that's why there was a 20 here. Then I go, what's another angle in there? It's 60. So the sine of 60 divided by 18. So that's step one. Then the second step is to multiply both sides by 20. And then I can cancel out this and this. So that leaves me with this one. And then I go inverse sine and I apply it like I did with the calculator. And let's try and do one more before we run out of time today. Can you find me the size of the angle Y using the, well, you can use whatever you like, but the sine rule would be a good idea. Ask yourself, what do you need to write down first? That's the key thing. What structure should you have? And whenever you use the sine rule, you kind of have this thing going on. And then ask yourself, what's the next step after that? Okay, so now when you've got this all in your calculator, you still need to get the Y by itself. And the way we do that is we have to use inverse sine or arc sine, some teachers say, and we have to apply it to this whole thing that was over here. So 21 times. It's a bit of a mouthful, but let's see what it looks like on the calculator. So I go shift sine, then I hit the fraction button, 21 times sine 84, come down, divided by 32.4. Then I go to the end, close the bracket, and I get 40.13. Or sorry, not 0.13, but 0.14 if I was rounding to 2 decimal places. If I was rounding, yeah, so 40.14 degrees. Just because of the 135. Okay, everyone, you have done exceptionally well today. And if you look back at what we did, we looked at when you're given certain pieces of information and you don't have right-angled triangles, you can use something called the sine rule. I didn't prove the sine rule for you today. I And I can prove it, but it wasn't necessary on this first lesson. But what we really learned was how to apply the sine rule to find sides, where we wrote the side on top. And then in the second half of the lesson, we learned how to find unknown angles using the sine rule, where we wrote the angle on top. And that was it for today.